Hi. So you guys know how to do this with the rules from grade 12, right? If you cancel it out, it's POD. If it's a non-permissible value on the bottom, it's an asymptote, right? So you can always use your grade 12 rules from pre-cal and check, but we're going to use limits to prove this. Okay? So I'm going to ask you to use limits to prove it. So determine the equation of the vertical asymptote of the function. So we know that our non-permissible value would be what? Negative 3. Did you throw it at me when my dog was wearing? So our NPV is negative 3. I guess x cannot equal negative 3, because if we put negative 3 in there, that would be 6 minus 2 over 0. Oh, no. Yeah. Oh, no, it would be a negative 8 on top. Negative 6. Negative 8 over 0, and that doesn't work. So we know right away if it's undefined, we need to do a limit left-hand side, right-hand side, right? So that's not good enough. So I do the limit as x approaches negative 3 from the left of 2x minus 2 over x plus 3. Not forgetting my brackets. So as soon as I see this, this is where you don't stop. This was yesterday's thing. You don't stop here. You have to do your left hand, right hand side limits. All right, so let's do our ish math, Kale. Let's do our ish math. Okay, go. So I'm approaching negative 3 from the left. Sure. So from the left, you're looking at negative 3.01. You guys would agree that that's less than negative 3? Small negative number over what's on top? Is it positive or negative? It's going to be a negative number, right? So we got a negative number on top, and we have a small negative on bottom. Where am I going? Big positive, so that's what? Big positive. What's the big positive number? Okay, so we did ish math. If you're not okay with the ish math, go back to your table of values. Okay? And then we're going to do the limit as x approaches negative 3, but this time from the right-hand side. Okay, so this time you're picking negative 2.99. And you guys always read that that's right of negative 3? Negative 2.99 is to the right of negative 3. Okay, so on the bottom, we have a small positive number. What's on top? It's still a negative number, right? So a big negative number, and our biggest negative number is negative infinity. Okay, so here's the thing that you need to know. If your limits are approaching infinities, that means that negative 3 is going to be an asymptote. Okay, so write this note down somewhere. Multiple infinities. Approach infinities. Okay, so that's the big important thing. If they actually approach a number, that means it's a point of discontinuity. So that kind of makes sense, because if we looked at the graphs that we did yesterday, anytime they were coming close to a vertical asymptote, usually you have the one going up and one going down. So if you prove it with limits, this is how I would do it. If they're going to infinities, we know that that number that the x is approaching is an asymptote. Okay? You know all these rules already from grade 12 pre-cal, but maybe even grade 11 pre-cal. But now we got something common going on here. What's x approaching? Infinity. We could, yeah. So, yeah, it's essentially exactly what we're going to do. So if we were to do direct substitute, that's supposed to be an infinity sign. If we were to direct substitute, you'd get that. Do you know what that is? I don't know. So we're going to say that it's undefined. And so x is doing something. X is doing something. X is approaching infinity, right? You guys with me so far? Yeah. Okay. So, can I qualify that? I'm going to add a word to it. It's a vertical asymptote, right? When we're talking about x approaching infinity, this is going to help us solve for our horizontal asymptotes. So x was approaching a number there, and it told us there was an asymptote at that number. Now we're saying x is approaching infinity. That's going to help us figure out what our horizontal asymptote is. So, can we do the two different types of asymptotes? So if we were looking at finding my vertical asymptote, what would the limit be that I'm approaching? 0. This may make it a little bit easier if we do both of them in the same example. I wasn't going to, but I think it'll make it easier. And we all know why 100 is 0? Because it's the non-permissible value for this equation, right? So if we're finding the vertical asymptote, x is going to be approaching the non-permissible value. And then we know that that's not going to work, right? Because I'll know that. That's going to give me an undefined. So let's talk about what's happening on, so as x approaches 0 from the left, what's happening? This is your ish map. 0 from the left. Give me a value close to 0. So you can think of 0.01. Took me a second to get there. So we have a positive number on top. We have a small negative number on bottom. Where are we going? Negative infinity. Okay, and then if we approach 0 from the right-hand side, what's the value of 0? Okay, there you go. Okay, we've got this Gish map down. Still a positive on top, but now it's a small positive on bottom. So where am I going? Positive infinity. So we know on this graph that we have a vertical asymptote at 0. Okay? So when it approaches the non-permissible value, that's going to tell you what your vertical asymptote. Yes? Are we good with that? When x is approaching infinity, we use that to help us find our horizontal asymptotes. So remember how in grade 12 and grade 11 I just gave you the rules Or Thompson gave you the rules, like the degree of the numerator is smaller than the degree of the denominator. You have it at 1, or the coefficients, or it's none, or, right? This is actually how you solve it. So, yeah, well, who knew? We just needed limits all this time. Okay, so let's go back to this. So this is undefined. So when it's over infinity, that's undefined. So what we're going to do, you guys all know where the asymptote is on this one? You know this graph. You know this graph intimately from grade 12. It's going to be on my x-axis, right? Remember that? So we should know that that's what our answer is going to be. But let's do it using limits. So the limit, that's supposed to be an n. As x approaches infinity from the left-hand side, 1 over x. What are some values headed towards infinity from the left-hand side? Sure. So -1. But that's going to be a little bit more difficult because -1 is just going to give me a -1 as an answer. It's not going to tell me a lot. So maybe let's do a table of values. Maybe let's do a table of values for this one. So I got -1, and we know my answer is going to be -1. Right? If I substitute that in. What's another one? Okay, let's get crazy here. Let's get even crazier. Okay, where am I headed? As the more negative I go, where am I going to? I'm headed to 0, right? And we know at 0, it's undefined because of this asymptote stuff, right? Yes. This asymptote told us that at 0, I'm going to be undefined because there's my vertical asymptote. Red and orange are probably not the greatest colors to use together, but there's no going back now. Okay, so now I'm going to approach from the right-hand side. So this stuff belongs to here. I'm running out of room. Is that UV? UD, undefined. 0 is undefined. No, you do? I can't wait. Did you write out some of your table values? Did you use the table values? You just did it. You just did it. Okay, so if we do 1, 10, and 100, we're going to have 1, 0.1, 0.001. Where are we headed to? We're headed to 0, right? So we know that our horizontal asymptote is going to be at 0. So where those rules were created from was from figuring out the limits of the function. What x is doing as it goes to its infinities. Okay? So if x is approaching the non-permissible value, that's going to tell you your vertical asymptotes. X is approaching infinity, that's going to deal with your horizontal asymptotes. Okay? That's what we're going to use this for. Now you can graph up those points and make the graphs, but that's what we use them for, is to find asymptotes. All right, you ready? Ooh, that was messy. Simple limit rules. Okay. I like to call these known truths. So these are my known truths. These are what I know to be true. So K, what was K when we did limit theorems? It was just a constant we multiplied by, right? So we know that if we were to use our limit theorems, you guys would agree? Yeah, limit theorem. the constant limit theorem, I can do that. Or I guess it would be a multiple one. We're multiplying by that constant, right? Okay, so if we have pulled this apart, less than 2. Yeah. This is your known truth. This here is your known truth. You've already figured that out. What do we know the limit as x is approaching infinity of 1 over x? You know, like you started, when we did transformations, you started with this graph. This was your perfect graph, and then you added stuff to it to move it, shift it, stretch it, right? So this is our known truth. What do you know that we just figured out this is worth? As x approaches infinity, what's the limit as x approaches infinity of 1 over x? You just solved for it. 0. Anything times 0 is 0. So if I gave you an equation, limit as x approaches infinity of 162 over x, you don't have to do any math. You know it's 0. Okay, so it's a known truth. Okay, we just proved it, but you don't have to demonstrate it. It's like a Pythagorean triple, 3, 4, 5. If you have the legs 3 and 4, you know that hypotenuse is going to be 5. You don't have to show it to me. You don't have to show me this math that goes with it. I mean, I guess if you really wanted to, you could. All right, so here's another known truth. You ready for this? Another known truth. Oh, I guess this would matter. Why does n have to be greater than 0? What if it was a negative? It would be a fraction where it's flipped to the top, right? And so if I had 1 over x to the exponent -2, really that's just x squared. So you wouldn't end up with a rational function. You wouldn't have anything that had lots of in it. So it wouldn't be responding the same way. So n has to be greater than 0 here. Okay, what's your power rule? Yep. What is this? 0. 0 to the exponent anything is? 0. So you see how having a known truth, like something that we know to be true, and just using that is super, it takes a lot of math away from it, right? Okay. So this is where your limit theorems come into play in example 2. So kind of awkward at first when we're learning them, because you're like, I can do direct substitution, and it's going to make so much more sense. Now, the whole purpose of this, when it's x approaching infinity, is to find that horizontal asymptote. So we're going to do this one, and we're going to bust it up. You ready? You're bust it up. Okay. All right. You know, these are things that I have a question for. Yeah. Okay, so if we substitute it directly in, like if we try to do direct substitution, this is going to put infinity here, and it's undefined. All right. So in order to do this, we need a fraction on the top, we need a fraction on the bottom. And the easiest way to do it is to multiply it by our known truth 1. So we're going to times the numerator by 1 over x, and we're going to times the denominator by 1 over x. This division gives me a value of 1. So I'm just changing the look of it. I'm not changing anything else. So I'm going to have the limit as x approaches infinity of 2 over x. I got 7x over x minus 5 over x. So now you see why the purposefulness of that is, because now everything's over has a denominator x, and I can start applying my known truths. All right, so we're going to use limit theorems to bust this apart. So we're going to do the limit of the numerator. Divided by, oh, and these x's cancel each other. Are you guys okay with that? I just do that quickly and stuff. Or I move on, I just don't, I'm being lazy. I don't want to write it all out. Okay. This is why limit theorems are handy. Because what do we know? We know that this is a known truth, so how much is this worth? 0. So I got a 0 on the numerator, that's okay. Limit theorem, when it's a constant function, just 7. And this one? 0. Yeah, so 0 over 7, which equals 0. So I would have a horizontal asymptote at 0. Is this easier to do than remembering the rules? The rules from grade 12, like this grade 2. If the degree is less on top, it's at y equals 0. If the degree is equal, like an x on top and an x on the bottom, then it's the leading coefficients divided by each other. So if I had like that one would be, this one would be y equals 2/5.
Oh, yeah.
Right? I need to do it with limits. I need you to do it with limits because I want you to understand them. That's a grade 12 book. Like that's a pre-cal outcome. That's a calculus. Okay. So this one has the highest. This one has the highest x squared in it. Or sorry, the highest degree is x squared. Highest degree is 2. So now instead of multiplying everything by 1 over x, we're going to multiply it by 1 over x squared. You always multiply it by the highest known truth degree. So we're 1 over x squared, 1 over x squared. All right, you guys ready for this? Okay. Okay. So limit as x approaches infinity, 2x squared over x squared plus 3x over x squared minus 4 over x squared from a numerator, 5x squared over x squared minus 7x over x squared plus 8 over x squared. Big brackets around all that. What if it was x cubed?
1 more x cubed.
Right. And if it was x to the 10th, it'd be 1 over x to the 10th. Those are your known truths. Like a 0 to the exponent anything is going to be 0. So it doesn't, it's not going to affect us too much. So those cancel out and those cancel out. What else happens?
Those x's.
So this will go and the squared will go away. This will go and the squared will go away. How do you feel about that? Not terrible? Okay, so, and I'm going to bust it out right into limit theorems right away. So I'm going to have the limit as x approaches infinity of 2 plus the limit as x approaches infinity of 3 over x minus the limit as x approaches infinity over 4 over x squared. That's all over the limit x approaches infinity of 5 minus limit as x approaches infinity of 7 over x plus the limit, whew, shoulder work up here, 8x squared. Okay, so let's evaluate those limits. First one, what does that evaluate to? 2 plus 0 minus 0 over 5 minus 0 plus 0. So my horizontal asymptote will be y equals 2/5. You guys good enough? Easy peasy? But that's where the rules came from, right? Like we gave you the rules, but they're all based off limits. And the non-permissible value thing comes from limits. So limits came before the tricks and tips of non-permissible values that you cross over. Okay, horizontal asymptotes describe the behavior of x approaches infinity, which we talked about way off to our left, negative infinity. Wise to assume that if a function has a vertical asymptote, chances are it probably has a horizontal. Not always, but it does. The horizontal line y equals k is a horizontal asymptote for the function of one following is true. So infinity, if f of x is going to k or negative infinity. Oh no, it's just what we just found. So that's kind of like the mathy part of it, but I think we understand it better when we do talking about it. Okay, page 4, look at that. We're already on page 4. Determine the equation of the horizontal asymptote using limits. I guess I should have put that. Okay. Guys, I stopped recording somewhere in there. Chris doesn't have any answers. Sorry, Krishna. I'll go through it all again. I think I hit pause when I told you guys to tell you. No, I told you guys to do this one. Okay. So Krishna, I'm just going to scroll through this slowly. We talked a lot about this. Proud of you. Sorry. Stop here. These are just your rules from grade 12. I'm really sorry, I forgot to keep recording.